Okay, we've got a word problem here, and notice that we're talking about minimum costs, and notice that there's an x squared here. You've got a parabola which opens upward, and the vertex will be the minimum value, and because cost is representing that c there, we know that this is a complete match here. So we're going to have to complete the square, and we've got this decimal involved. We're going to write c of x is equal to 0.3, which we're going to factor out, times x squared minus, okay, now I've got to take that negative 90, divide by 0.3, and find out that we're going to have a 300 in the middle of our equation. Put a blank in, close parentheses, and move your 25,136 over to the right. Now what we're going to want to do is complete the square process, subtract or cut in half, get negative 150, square this to 22,500, which really isn't what that value is because there's that 0.3 out in front. When we multiply by that, we've really added 6,750, so we have to subtract 6,750 on the right there to compensate. Completing the square, we have x minus 150 squared, the 0.3 out in front, there's our c of x on the left, and subtracting over here on the right, we have plus 18,386. Now we can identify that the vertex is going to be at 150, 18,386. It's asking what is the minimum cost. Well, that's pretty easy. Now the minimum cost is going to be 18,386 occurring at the vertex, and you can actually say when 150 dresses are produced. And that gives us a little bit more information about the context of this problem. We've got another word problem, and this is going to show up quite a bit in your upper mathematics, so it's something we need to get used to. We have negative in front of our t squared, which tells us we're going to have a parabola opening downward. And if you think about this, we're talking about a maximum height, and when a parabola opens up downward, there will be a maximum. So I'm going to rewrite h of t in standard form, negative 16t squared plus this 112t, and put a blank there. I'm then going to factor out the negative 16 and have t squared minus 7t, leave a blank, close our parentheses. Now it's time for us to complete the square. Negative 7 will cut in half to negative 7 halves, and square to 49 over 4. Now, that's not really a 49 over 4, it's negative 16 times that. So it's negative, we're going to have to add to compensate. The 4 will cancel with a 16, making 4, and 4 times 49 is 196 that we're going to have to add to compensate. Completing the square, let's put our t in, our parentheses, our quantity squared, the negative 16 out front. Height is a function of time, and now it's in a nice neat form ready for us to recognize. We can see that the vertex is going to be at 7 halves, 196, and the maximum height that we're looking for in this problem is going to be 196 feet. Now it's going to occur at 7 halves or at 3.5 seconds. Now while we're looking at this problem, let's take a look at another concept here. We have height as a function of time, and we know that we're going to have a parabola drawn in here, and it appears we're going to have a maximum height here. I want to call to your attention that this is not a graph of your flight path of the ball that's being thrown here, because it told us that this is being thrown vertically upward. A flight path would just go straight up and straight down. This is a graph of height versus time, not a picture of the ball being thrown and where it would land. That would be height versus distance away from the thrower. In this problem, we're being asked to find the maximum area. And these max-min problems show up along with quadratic equations, and we want to draw a picture of this situation. And if you haven't read it, please do so and pause this for a moment. I'm going to draw right here our house, and we're going to have this rectangular enclosure or pen set up with the house being one side. And I'm going to say that we're going to have two widths and one length right like that. And we're trying to find the maximum area. What we always do on these max-min problems is first write an equation for what we're trying to maximize. We want the maximum area. Now the area is going to be length times width. But we've got to use our other information here dealing with the perimeter. We know that our fencing is going to be along these dotted lines I've drawn here, and that 2W plus L is going to add up to our 40 feet of fencing. So we've really got two equations that we want to work with. Now, you know as well as I do that we can substitute one into the other, but we're always going to substitute the secondary equation into the max-min equation. I'm going to isolate the L, write this as negative 2W plus 40, and substitute that into the equation dealing with area, because area is what we're trying to maximize. That will give me area is equal to L times W, which becomes negative 2W plus 40 times the other W. That will be our quadratic equation, and I'm going to start right there. We're going to have negative 2W squared plus 40W, and you can see the quadratic nature showing up now. I'm going to factor the negative 2 out, leaving me W squared minus 20W, leave a blank, close my parentheses. Then I'm going to do my complete the square process. Cut the negative 20 in half to a negative 10, square it to 100, but that's not 100, it's really a negative 200, so I'm going to add 200 over at the right to compensate. Completing the square, I will have W minus 10 squared, negative 2 out front, let's bring our A down, plus 200 at the right. We now can identify our vertex to be at 10, 200. But let's look at the variables also. Isn't this a W equals 10 because it was W minus 10? And instead of Y, we've got A, and so that 200 is representing the area. So they want us to find the maximum area, and that maximum area is going to be 200 square feet. Now, when is this going to occur? Well, the answer is when W is equal to 10, and L, well, we can find L by substituting up into the top into L equals negative 2W plus 40. That becomes negative 2 times 10, negative 20 plus 40, which is 20. So the width would be 10 feet, the length would be 20 feet. And notice 10 times 20 does make the area of 200 feet, or square feet.